Here we have chosen one important problem. The problem is how many zeros are there at the end of 1000 factorial. And this problem is important in Olympiad examination as well as CSIR NET. And this is one of the best problem in number theory. And when our problem will be solved, after that you will try the number of zeros at the right end of an integer in factorial, where just you put the position of in your birthday year. So now we come to the problem. As an example, here you take n equals to 1000. So the question is how many zeros are there at the right end or at the end of 1000 factorial. A number of zeros at the right end of an integer 1000 factorial is, there are few options: 200, 249, 494 and 994. So for solving this kind of problem, we must recall one important basic facts. The fact is basically about the largest exponent of a prime. So how you will find out the largest exponent of a prime when it is a divisor of n factorial? So there is one important theorem. The theorem is the largest exponent e of a prime p such that p to the power e is a divisor of n factorial, where the exponent, the largest exponent e is given by this formula: e equals to n by p box function, or you can say the floor function, plus n by p square box function plus n by p cube box function, and so on. But okay, here we are interested to find out the number of zeros at the right end of the 1000 factorial. That means if you calculate 1000 factorial like this: 1000 multiple 999 multiple 998 dot 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 multiple 3 multiple 2 into 1. It's a huge number and it will take more time. So for reducing the time, what we will do, we will apply this kind of basic facts and we will follow the steps. So that means we need to find out the number of 10 at the end of 1000. If we think about 10, so how many zeros is here? 1 0 at the right end. So I will think about, you need to think about the exponent of 5 and exponent of 2. You will see 5 multiple 2, it creates 10. Again, if we think about 5 multiple 5 multiple 2 multiple 2, that is basically 100. So that means the number of zeros at the right end is basically depend on two prime numbers. One is 5, another one is 2. So the pair and 5, 2, this pair, and if we multiple this pair, we will get 1 0 at the right end. So that's why you need to think about the largest exponent of the prime 2 as well as the largest exponent of the prime 5. So that means we need to think about the 1000 factorial, how many 2 to the power e1 and 2 to the 5 to the power e2 is present, and that there may be another number 7 to the power some e3, but we are interested this first two term and the exponent of e1 e2. So here are the steps for finding the number of zeros at the end of n factorial. First step, step 1, find the largest exponent of e1 of the prime p equals to 2 such that 2 to the power e1 divides n factorial. And also we have to find out the largest exponent e2 of the prime p equals to 5 such that 5 to the power e2 divides n factorial. Now the one pair 5 and 2 that makes 1 0 at the end of 1000 factorial. So that's why you need to think about at the end of n factorial. In fact, we need to think about how many pairs are exist in the number n factorial, and that pair is basically 5 and 2. So now we need, for the finding the number of zeros, we need to think about the number of zeros is basically at the right end of n factorial. That will be minimum of the exponent, largest exponent e1 and e2. e1 is basically largest exponent of 2 and e2 is basically largest exponent of 5. So what we will do, We'll think about first the largest exponent of 5, or maybe the largest exponent of 2, as you wish. So the 1000, if we think of largest exponent of 2, and that we consider as E1. So E1 will be 1000 by 2 box function, or you can say the floor function. 1000 by 2 square plus 1000 by 2 cube plus 1000 by 2 to the power 4 plus 1000 by 2 to the power 5 plus 1000 by 2 to the power 6 plus 1000 by 2 to the power 7 plus 1000 by 2 to the power 8 plus 1000 by 2 to the power 9. And if we take 2 to the power 10, you know 2 to the power 10 is basically 1024. It is greater than thousands. And after that, we'll get the box value is basically 0. So this value is 500 plus 250 plus 125 plus 62 plus 31 plus 15 plus 7 plus 3 plus 1, and it will be 994. You only have to find out the largest exponent. This is basically the largest exponent of the prime p equals to 2. Now we move to step 2. We need to think about the E2, that means largest exponent of p equals to 5. That will be 1000 by 5 box plus 1000 by 5 square plus 1000 by 5 cube plus 1000 by 5 to the power 4. And you know, if we take 5 to the power 5, that will be greater than 1000. After that, all the box value will be 0. So this number will be 200 plus 40 plus 8 plus 1. That means 249. Now we'll apply step 3, step 1, step 2, and step 3. The number of zeros at the right end of 1000 factorial, that will be minimum of U1, E2, that means minimum of 994, 249, so that is 249. So here the answer is 249. So that means 249 zeros are present at the right end of 1000 factorial, and hence the option B is correct. All other options are false. Thank you so much.